lengthy wires. I was the only group member in this experiment. What inspired this lab was the placement of nodes and antinodes proportional to the length of an object, meaning the longer it is, then the farther apart the nodes would be, and shorter, the closer they would be. The variables were an independent variable of the length of the string, dependent variable is the frequency of the sound waves, and constants are string type, string tension, and hopefully pluck strength, along with the usual others. My question was, what is the relationship between the length of an object and the frequency of the sound waves it creates? My hypothesis was that if the length of a constantly taut wire is plucked when at various lengths, then the shorter the wire, the higher the frequency, because the wire cannot be displaced as far from its equilibrium. My materials in my instrument were PVC, wire, shoebox, glue, and wood. I also used a microphone and Audacity for this lab. My procedure was set the splitter, as shown in the picture, to 0 centimeters, start recording Audacity, pluck 6 times, end recording, plot the spectrum in Audacity, and average all the peak or audible frequencies, and repeat with the splitter at 0, 5, 10, 15, or 20 centimeters. Please note, though, that the actual length of the wire would be 45 centimeters minus the setting of the splitter. There's a data table showing 0, 5, 10, 15, and 20 centimeters of the splitter, the actual string length, the frequency, and the musical note that it creates. This is the graph of it. It is polynomial and decreasing at a decreasing rate. It was polynomial decreasing at a decreasing rate, and meaning that the farther left on the graph or shorter the string, then the higher the frequency, and the longer the string or farther right on the graph, the lower the frequency. Conclusion was that the relationship between the length of an object and the frequency of the sound waves it emits is polynomial, decreasing at a decreasing rate, supporting my hypothesis because the shorter the string, the higher the frequency. The equation, however, is not correct for zeros, as there will be no zero length or 0 hertz. Errors could be slight wear and tear on the wire, splitter may slightly move during plucking, external mic interference, or differing pluck intensity. However, I tried to keep that constant. Some extensions from this lab may be the relationship between the tension and the frequency and musical notes, and off of that, would that be different on various musical instruments.